Welcome, everyone. Let's see. Slides. There we go. When a patient walks into a doctor's office, there are two conversations that take place. The first one is the identification of problem areas, things that might actually occur, catch them early, diagnose, and fix. And the second conversation is about leading a healthier lifestyle. Those two conversations are similar to what happens when you sit down with your code, whether you're talking to yourself in the computer or whether you're speaking with a larger design and development team. The first question is, how do I write an optimized, healthy application? And then the second conversation is about how do I monitor my problem areas, my potential areas, and debug the situations as they go on. Very often, performance issues are unintended side consequences of a decision that was made for the user's best interest. Let me give you an example. Back in WPF days, the performance team was approached about a text application. All it did was display text. Unfortunately, it was chugging out the CPU and couldn't figure out what was going on. We checked enable redraw regions, a flag that I'm going to talk about later. We checked the frame rate counter, again, some weird drawing patterns. And so what we did was there was thousands of lines of XAML, code, et cetera. But the worst issue was that when the user tried to scroll static text, it would go thunk, 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 thunk. It would not smoothly scroll. And when I describe smoothly scrolling, I'm talking about a regular frame rate over around 30 to 60 frames per second. Not knowing what to do, not our code. We just started removing the layers, the media, the text, the panels, and slowly we uncovered a 3D dancing bird. Now, what had happened was the designer had created this little mascot for the newsreader application, and then decided that it was a little ugly, and so before everyone came back from the holidays, stuck it into the back of the Z order, correctly assuming that the graphics pipeline, and this is true of Silverlight too, anything invisible will not be blitted to the screen. However, although a very small little bird, it's a very complex bird, and anything hitting the 3D pipeline on WPF or on Silverlight for the animation system, calculating dance moves are actually a little expensive. And so this was with the user's best interest in mind, but forgetting the fact that the primary purpose here is to scroll text. It is not to display and calculate dance moves. Another unintended side consequence is when every so often a Silverlight application will show up and they'll be like, hey, you know what, this is taking a really long time to start up. And then, we go through the designer and we pull it up. And this happened a couple of weeks ago. There were 17 list boxes in the background. And this actually happens very frequently, is that we wireframe and prototype the entire scenario, forgetting about startup, or that Silverlight's going to actually do what you ask it to, create those 17 list boxes, or create those 5 dozen Bing Maps controls, what have you. My name is Seema Ramchandani. I'm the Silverlight Performance and Graphics PM for Silverlight on the Windows Phone. Every single keynote demo that you saw yesterday had gone through our team. I'm going to raise your hands over here. There we go. We sat for the last 3 weeks going through their code, tweaking it, and educating the demo teams about how to write a better Silverlight application. And today, when you walk away, I want you to be able to have that conversation with your application that we talked about earlier. 1, how to lead and write a healthier lifestyle. And 2, how to actually fix and debug any issues that might occur. And then, just for reference, I'm not going to be talking about networking. I'm not going to be talking about a large range of subjects that will also affect your performance. And so if you have any questions, contact me via my blog, and we can have an ongoing conversation between conferences. There are many different applications that are actually written very well with Silverlight. Let's give you a couple of examples. So this is a very simple list box. I cleaned my phone for you guys so you don't see grease stains. Actually, let me stand up here. This is a list box with 550 items. It starts up fairly quickly. There's no data virtualization, but if you wanted to, you could actually implement it. focus. There we go. Turn it off when it's focused. Why? OK, never mind. Here we go. What we're doing is we're triggering an animation on the flick event. It looks a lot smoother here, and I think the frame rate of the Wolf Vision is not actually helping here. But basically, what we're doing is we're triggering an animation on the flick. The animation is moving textures on the GPU with instructions to move them with a translate transform. UI virtualization is being used. I'm going to go through all these concepts today. The next demo that we're going to see is one that you saw from yesterday. How many of you guys saw the AP app by Archetype? Pretty smooth, right? Did you see that? Do you want to see it again? UX transitions that target the perspective transforms are going to be very smooth in Silverlight because they leverage the GPU and our off-thread animation system. Very simple, very easy to build your application to have the UX transitions that will actually leverage the GPU pipeline well. It is important to think about this with your designer and developer teams. How many designers do we have in the room right now? And how many of you have designers in your company who are not at this talk right now? Designers need to be involved in the performance of your application and thinking about how to actually optimize. I know often the workflow is make it look good, and then I'll make it look fast. But designing for fast on a 1 gigahertz device is actually, oops, battery fell out, is actually not, designing for the 1 gigahertz device is a conversation that all of the development team has to be involved in. Let's switch back. Wrong laptop. There we go. Okay, I don't know why there are 10 switch blocks this year. There we go. And that was done by the Archetype team. Moving back. When you think about building an application, this is sort of the pyramid on which we build all of our decisions. The first one is less is more. The concept that less activity, smaller code tree, and less rendering redraw regions is going to actually improve the experience of your application. We'll talk about the thread system on Silverlight on the Windows Phone and how that differs from Silverlight on the desktop. And we're going to talk about leveraging the GPU, also differing from Silverlight on the desktop. How many of you guys have built with Silverlight on the desktop before? Great. And how many of you guys have developed for the Windows Phone or another phone device? Great. OK, so we have quite a bit of overlap. Excellent. Less is more. Let's begin. Keeping an eye on your application is going to require you to do a little bit of eavesdropping. And we'll give you some tools to do such. We want to iteratively measure the performance, identify early what the issues are going to be, whether it's startup, memory, frame rate. You can probably guess what these are going to be, knowing just a little bit about what you're going to build. We want to monitor these attributes as changes are made. And then, and I know that you guys don't have devices today, but when you do, test on the devices regularly. And we're going to work, and we are working as hard as we can to fix that and get devices to you. But when you have them, test every day, OK? Because I've seen way too many applications that are built to work on a Core 2 Duo and not on a 1 gigahertz device. Listbox, the one that we saw earlier, is designed with a couple of different concepts to apply the less is more principle. The first one is UI virtualization. We introduced this in Silverlight 3, and we fixed a couple of issues that we had that sort of cropped up on the smaller device. In the list box, what is actually there's a data collection of 550 items. The ones that actually have a visual tree, those 2 text blocks, the path on the side, There's 6 of them that are visible. Those 6 have a visual tree. And then there's 5 above and 5 below. Those are hard-coded right now. As you scroll, we recycle the visuals so that we're not reallocating a new visual tree every time. And we've right now optimized for fixed width and fixed height. And we're going to actually try to optimize for unfixed height and width by ship. I don't use data virtualization here, but this is a concept that you can actually leverage. If you have your data collection on the server, you don't want to download it immediately, or if you have it in isolated storage, you can just upload only the 50 items that you need at any point in time. We're going to leverage the threading model. On the list box, actually, when you do the flick, we're going to be doing the work not on the UI thread, which is supposed to be saved for input, but instead leveraging the render thread and the GPU. Silverlight's animation system is a real-time system. Think of it as a film strip that is moving by. So let's say that you're at the second frame, 33 milliseconds. Just a quick note. Right now, as we ship, we're at 60 frames per second. In today's bits, we're at 60 frames per second. When we ship, we are going to be limited to 30 frames per second, and we're going to have this working assumption in the talk. So every 33 milliseconds, we try to show a frame. If available, the UI thread will actually show and draw the next frame. If it's not for some reason, let's say it's handling input, and for some reason you have to skip 3 of your frames, in a frame-based model, we would return at the next frame. But Silverlight is a real-time-based system, which has its advantages for interacting with media. And so we return to where it should be at that point in time. 132 milliseconds. At 132 milliseconds, you should see that scenario at that point in time. This is the loop that we think about that is going behind the scenes anytime we paint a frame. So when the timer goes off, every 33 milliseconds, we do a tick. We check to see in the tree, are there any property changes? And then if we have a property change, some of them will affect layout. Color will not, width and height will. Layout system in Silverlight, and this is exactly the same as on Silverlight Desktop, is designed for nesting, and it's an extensible model, so people can add on their wrap panels and animating little fancy thingies, dock panel, what have you. We do a 2-pass system. We first walk through the tree recursively for a measure. How big are you? How big are your children? How big are your children's children? And then we next go and say, okay, well, you know what? I know that you want 3,000 pixels in height, but you only get 800. So let's walk back down and arrange at the size of 800. And at that point, Scroll Viewer says, oh, let's add in a track or scroll bars on the desktop, et cetera. This is the same as on Silverlight Desktop. After the layout system occurs, and walks through the entire tree, we queue up all of the rendering changes that happen per scene. Notice that this happens once per frame. If you have 5, 10, 15 animations going on, we're only rasterizing 1 back buffer at any point in time. Generate all the changes, and then we present it to the compositor and ask it to show our frame. Notice that this is very much like a coffee cup. So this is often my problem. Is that when I'm drinking my coffee, or chai, whatever, is that what is throttling the output is actually what's going inside. So if your UI thread is throttled, it will actually limit the number of frames that come out. So we'll talk about leveraging the UI thread for your transitions to be smooth. The way to track the frame rate counter is actually by turning on this flag, enable frame rate counter. I was told that this slide looks creepy, so here's a more cartoon-like one. And we'll go through the different values. The second one is the one that we're going to talk about first. It's the UI thread frame rate. To capture, again, smaller visual tree, less code activity, and less activity will make for a healthier application. Sort of like sodium and less cream and sugar. So we're going to use redraw regions to figure out what's going on behind the scenes. Redraw regions is sort of like visualizing the pain point or asking the patient, where does it hurt? How often does it hurt? What sort of triggers the situation? And like, how frequently do you get the pain? So enable redraw regions will allow you to see exactly that on your application. It will identify what is drawing, how big is it, and how frequently. And if you're epileptic, please close your eyes. So, oh, I think I forgot it. When the battery fell out, I forgot to turn it back on. Give it a second. So basically what we're going to see with redraw regions is every single frame, we redraw what is dirty. And then for redraw regions, when it's on, we will tint it with a different color so you can actually visualize what is being drawn when, where. Very simple concept. How many of you guys have used this flag in Silverlight before? Okay, all of you guys should be raising your hands if you've developed on Silverlight. This is a very important, useful flag. So we only draw what is dirty, and we can do that as far as we can figure out. But some of you guys have written physics engines or algorithms that actually push property changes, and so sometimes we're a little too sensitive to that. So you might be changing the property by like 0.001 pixels, and we're thinking, okay, sure, we'll redraw it. Oh, look, there's layout, there's a huge cost. And the user's not seeing any difference. This is very simple. This is very similar to the hidden peacock or bird. So always double check. Turn on redraw regions. Make sure that what you're drawing and what you're paying for is exactly what your user is seeing. How many of you guys have been in a Prius? And what's the weirdest thing about a Prius when you get to a stoplight? It turns off. Right? That's exactly what your application should be doing. So if your application is doing nothing, don't cost any redraws. So now we know basically what's drawing, where the pain points are. So let's actually sort of stress test it a little bit. This is sort of like the doctor saying, well, your heart's a little weak. Let's put you on the treadmill and see how well you do if you pass out. So we're going to talk about the threading system, and there are 2 frame rate counters to be kept in mind. 2 threads, 2 frame rate counters. The first one is the render thread, second one is the UI thread, and then there's some child threads that we spin off for C-Dragon, rasterization, media decoding. Don't worry about that stuff so much. The render thread will handle simple animations of simple properties. Specifically, double animations, built-in easing functions will leverage, and those are the ones that Blend uses. Simple properties, render transforms, perspective transforms, opacity, and rectangular clip. And mind you, this is without opacity mask or non-rectangular clips. And you're going to hear me say this a lot. We can actually put those animations off thread. We can do all the calculations of the property changes off thread. The UI thread generally should be reserved for input. I know a lot of you guys have written applications with game loops or per frame callbacks. It's an interesting concept. Silverlight is not designed to work with that. Keep the UI thread for input and user interactivity, and use the render thread for your UX transitions. That's actually probably the safest rule. The other things that happen on the UI thread include control code, user code, layout, other animations. The beauty of this is different from Silverlight Desktop. The beauty of this is that if you have some sort of like progress animation, like, hey, I'm downloading some stuff on the network, I'm building up my visual tree, I'm executing this code, on the side, you can actually have a simple UX transition occurring on the render thread. Very simple, very beautiful. And this is actually tracked by the second frame rate counter. The first render thread was on the first frame rate counter. Again, remember, you can throttle the frame rate on the UI thread. The render thread will be a lot more independent. UI thread will handle input. And input is different on the device than it is on the desktop. Expect it to take active input around 15 to 25% on the device for CPU. This is very different from desktop. And that's outside of the Silverlight code base. The frequency of events will range depending on the hardware. And this is just a natural thing about being that much closer to the metal on a device. We've talked about 2 of the frame rate counters. Keep them in mind. Watch them. If you're ever building an application, I want to see this frame rate counter on. And I want to make sure that you're accessing the GPU, and I want to make sure that you're actually watching and measuring constantly. So now we know a little bit about the patient's pain areas. We know a little bit about the frame, like we've stress tested it. Now it's important to understand how the organs, sort of the system works together. Let's talk about leveraging the GPU. This is sort of our heartbeat. Pop quiz. How do we check for GPU access? If the enable frame rate counter is on, then you will get blended on top the frame rate counter. If you do not have GPU access, then you will not get any frame rate counter. And if you've downloaded the emulator, this is actually the easiest way to check. The emulator only has hardware acceleration if you have a WDDM 1.1 driver with this CTP. And we're working to widen that range of hardware later on. Let's talk about caching. How many of you guys have used caching in Silverlight 3? Couple of hands. How many of you guys feel like you've used it effectively? Actually, keep your hands raised. OK. We lost about 2/3 of you, unfortunately. Vector graphics can be very big. This is a bear. It's a teddy bear that was in one of the samples for the expression design. There are 13 pages of XAML if you print this out in Word. And if you actually try to do this with vector graphics, it's going to create a very complex edge store. A cache bitmap, what we could send to the GPU, is basically a bitmap of those vector graphics, not the edge stores, just the simple bitmap. And basically, if the content is static, we can start treating it like bitmap, and that can be a little bit cheaper. Notice that the cache is taken very early on in the scene. So we render all the children, we cache it, we take basically a writable bitmap of what it looks like, the equivalent. And then we can apply the following properties on the GPU and ask the GPU to compose it: the opacity, effect, rectangular clips, etc. The way we would do this is at the very top of our XAML, at the visual root, we would set cache mode equals bitmap cache. We do this somewhat automatically for you in certain cases. If you are leveraging a render thread optimized animation, we will auto cache it. And again, this is if you have no opacity mask and non-rectangular clip, because we don't have those instructions on the GPU. The element will be auto cached, and so not only is the properties actually calculated off thread, but additionally the composition is done not on the CPU but on the GPU. So let's look at a sample. Let's hope that my machine has booted up. This doesn't seem to be turning on. I'm good. You know what? I think we're good. We'll come back to it. Sorry about that. Can I borrow your? Oh. Somebody else get their device ready, because we might have switched. OK, so we want to empower the designers, specifically leveraging the render thread and UI threads properly in our UX transitions. Again, this is a matter of designing your application, knowing the Silverlight for Windows Phone architecture. Transitions are smoothest if they are leveraging the render thread capabilities in the GPU. So render thread, opacity, perspective transforms, and rectangular clips on mostly static content. If the content changes a little bit, that's fine. And I don't mean in terms of size. I mean in terms of frequency. Because every time that we incur a change on the CPU, then there's some work that's going to be done on the UI thread. Again, without opacity mask and non-rectangular clip. Double animations will not interfere with the user code. And that's great if you're doing some developer work behind the scenes of the UX transitions. So, little pop quiz, which thread is being used? The first one is a color animation, and the second one is a double animation targeting a translate transform. So what UI thread... Okay, well, what thread is being used for the translate transform? No. Okay, what thread is being used for the color animation? The UI thread, exactly. What thread is being used for the translate transform? The render thread, because the translate transform can be executed by the GPU, and so therefore it's off thread. And that gives me to the second question, which one is being used by the GPU? The animations done by the render thread, the translation transform, can be executed on the GPU. The color animation will be done on the CPU. Oh, look, we have a device. Is it my device? Yes. Oh, great. Thank you. So I want to show you a couple of different demos, because we missed out at the beginning. Well, I don't know why the button's on the side. Let's go. So basically, for half of the time, we have a color animation going on. And then the other time, for the rest of the time, we have a translate transform constantly going. If you turn on Enable Redraw Regions, you'll notice that while the color animation is going on, while the CPU is involved, you will see it flicker or flash, because that's what Enable Redraw Regions is telling you. It's telling you when the color animation is going, we're actually getting some redraws. When only the translate transform is going on, we don't have any CPU composition. Let's go back. Go to the next demo. This was an app written by Shane. He's our test lead for performance. What's going on here is we actually have very smooth transitions, perspective transform coming down on each of the animations. Then he takes a writable bitmap of the scene, and then he moves the used picture back to the top, translates it, and continues the animation going on. Now, the writable bitmap on Silverlight desktop, this scenario would actually cause a stutter, because the writable bitmap is going to be executed on the UI thread. What we introduced in Silverlight on the Windows Phone is the off-thread animation. And so even though we're doing that work on the UI thread for the writable bitmap, it's not stuttering or interrupting the animations. Another demo. Demos are fun. Let's see. Did I show you guys the list box? Or did you guys miss it? I did show it to you? Yes, I did. OK. There we go. Very smooth. And the reason why is that we're doing a translation transform, which is off thread. And then the GPU is doing all the calculations of where those items are, translation, and then a clipping of how big the list box is. The AP demo is very beautiful. Because what it's doing is actually leveraging the GPU for its transitions. The UX transitions that are designed are actually perspective transitions. And as we animate them, as I up it, this can all be done on the GPU, right? So all can be done off thread and all done on the GPU. This is why it's important to talk early with your designers about how to build UX transitions that look beautiful and can perform beautifully. OK, back to slides. There are certain situations where you will want to employ the GPU manually. We're not doing an animation. Instead, we're doing, what have you, a per frame callback, or you have an algorithm with a physics engine, et cetera. Again, we want to manually cache in the same places that we would auto cache. Render transform, perspective transform, opacity, rectangular clip, no opacity mask, no non-rectangular clip on the self or parent. It's OK if it's in the children. What's happening with the list box is we're going to cache each of the nodes. And the reason why is because although the flick triggers an animation, when you're panning, there's no animation. So we actually want the still to take advantage of the GPU. So we set cache mode equals bitmap cache in the list box item code itself. If you check the value, the default value of cache mode, you're going to see that it's bitmap cached. And then we apply a translate transform simply in layout. Layout's just saying, hey, there's a stack panel, and it's changing the location of each of the items. And that just translates to a transform instruction to the GPU. And then, of course, the rectangular clip. This is how you can write a very high-level concept of a managed control, leveraging very low, gritty GPU details. So let's say that we were trying to compose a scene with kittens. And I just want to illustrate a little bit about where to manually cache. So the scene is the kitten is reaching into the goldfish bowl, and there's some horses that are moving around, and you have Humpty Dumpty in the background. OK, so what's going on? What should we cache? The designer has given me this ridiculous scene. I don't know what's going on. What do I do? The intermediate texture, there's an intermediate texture that is created for the background. And basically, that is counted in the very last frame rate counter. Anything that is static will be actually included in the background intermediate texture, as long as there's nothing that is cached before it. We'll talk about z-order in a second. We then have two items that are getting animated. If they weren't animated, if it was like an algorithm or physics engine that was driving them, then I would set cache mode equals bitmap cache. Then the GPU would be executing the composition of those things. And then there are more complex things in the scene that are animations that are not simple dumple animations. And so we do not want to cache those. It will not give us any advantage. So if my code looked something like, canvas, Humpty Dumpty, seahorse, cache seahorse in terms of they're actually moving, then what I'm creating is a visual tree that basically looks like this. We have an intermediate for the background that has all of the items that are uncached, and then two smaller textures that are created for each cache node. The third frame rate counter counts for the amount of video memory used by the scene. And this is basically an addition of all the textures that are being used. If, let's say, that we reordered Humpty Dumpty to be in the middle, it wouldn't have any visual effect to the user, but it would have a very large effect in terms of what textures are created. And the reason why is because we're interleaving bitmap cache and non-cached. Because what happens here is that we're going to create the same intermediate for the background. We're going to create the cache node for the moving seahorse. We're going to create another intermediate for the item that is not cached. It's shrunk to the texture. This is unlike Silverlight Desktop. Silverlight Desktop would create you a large texture. We shrink this texture to the size, but we also have this fourth cache node. So instead of only blitting 3 textures every frame to the GPU, DirectX is an immediate mode system, so we have to blit every texture every frame. We're actually doing 4, and that can be a little bit more expensive. So again, just be aware of the ordering of your visual tree, and just try to minimize interleaving. This is a concept that developers will probably be more responsible for than the designers. So we've gone basically through all 5 frame rate counters. I think I missed D. D is the total number of textures on the GPU. So on a list box, for instance, it would be the background, the 6 or 7 items that are seen, the 5 items above it, the 5 items below it. You'll basically get a total number of all textures blitted every single frame. There are some special cases for employing the GPU. The first one is elements with blur or drop shadow. And use effects carefully, because again, this is the cost of textures. We've just discussed that. I don't know why the lights are turning on, but it's quite nice. You're seeing the light finally. Sea Dragon, multi-scale image. We use and leverage the GPU for opacity, blending, and resizing of the images. So turn on multi-scale image cache mode equals bitmap cache. I think the default has been changed in the bits that you have. And then media element. Let's talk about media element. Media is a rinse and repeat cycle. Just like when you're using shampoo, decode, YUV convert, resize, blend, draw. This cost is incurred for every pixel, every single frame. So count your pixels wisely. The YUV convert is basically, media generally speaks the language of luminance, chrominance. We speak the language of red, green, blue, so we just do a little bit of conversion. Since it's a rinse and repeat cycle, remember to encode at the minimum frame rate possible. Sometimes people use media as background, not necessarily the primary purpose, or maybe it's like a commercial, or I remember, like let's say you have commercials embedded, you want to encode at the minimum frame rate possible. Again, encode at the smallest desired size. This is true for desktop as well. Wherever the scenario is, decode only the pixels you need. Well, so first of all, media effects doesn't work in the CTV, but I don't want to enable it, but we're going to enable it, because media effects is a perf no-no. Basically, you're going to decode the entire video, and then you're going to take a snapshot, apply the effect, and you're going to do that, pay that cost every pixel, every single frame. So I would just avoid media and effects. So if you're writing a media player, and it sort of looks like that, this is my beautiful MS Paint job. The background, final buffer, created. This is true for desktop as well. You want to use the cache the media element. And basically, the media will, on the Windows Phone, will be decoded in hardware and will be stretched and blended in hardware. And then we want the top-level stuff to also blend on top of hardware. So if you're doing this on desktop or mobile, cache your media element. Enhancing the media with the GPU, basically, all you need to do, set cache mode equals bitmap cache, and then you want to use your normal debugging tools. Enable frame rate counter, redraw regions. That's very useful if you have a progress bar. Do you see this frame? OK. The top level stuff, it doesn't need to be that big. We're paying that cost for the size of the top level canvas. You could actually shrink it to be just the height that you need from the progress bar to the thumbnails below. So make sure that you're only redrawing and blending where you need to. And of course, enable cache visualization. This is another debug flag that I'm introducing. It basically draws the hardware surfaces normally, tints software surfaces, and it'll give you a good idea if you're successfully engaging the hardware pipeline or if there's opacity mask, what have you, in the background. Change. There we go. OK. The media decoders on Silverlight for Windows Phone only, this is Windows Phone only, not desktop, will be hardware accelerated on all devices. This is all of our media decoders. The ping decoders are going to be executed on the CPU, and the JPEG decoders will be hardware accelerated on some, if not all, devices. I think that's still TBD. The scroll viewer example. Can I leverage the GPU? So my key concern is scrolling here, which is basically a translation and a clipping, just like in ListBox. But we're not a list box, so what do I do here? I know my tree above and below. I know that there's static content below it. I know that nothing is changing while I'm scrolling. And I know that there's no opacity mask or rectangular clip, non-rectangular clip above me. I also know my explicit size. This is key. The max texture size on the device, actually both on desktop and mobile, is 2048 in any single direction. Don't multiply and try to tell me that it's smaller than that. It's in any single direction. So if you have a stack panel that is 3,000 pixels, you cannot hardware accelerate. We cannot allocate that texture on DX. So we would fall back to software. So let's look at the little bear. Oh, hello. So again, a very, very simple concept. Basically, what we're doing here is we have 3 of these bears in a stack panel. And as we scroll, let's see what's happening if we do not cache this. So if I flick, I'm triggering an animation. It's a little bit smoother. If I pan, junk, it's not even moving now. OK. Oh, no, I'm at the bottom. That's why it's not moving. OK, chunk, chunk, chunk. Not beautiful. We're at 4 frames per second. Can you guys see that? Can you guys see the frame rate counter up on top? OK, those who can read it, it's basically saying that there's 4 frames per second while I'm scrolling. OK, well, I'll tell you, it's 4 frames per second. I think you guys could probably tell that by counting. If we turn on Enable Redraw Regions, we can actually see what's happening. That edge store is actually getting recalculated every single frame. We're actually doing all this composition on the CPU because it's not handled or cached. If we instead cache the items, now notice my stack panel is actually, I think, 3,000 pixels in the scene. And if I cache each of the individual items, it will perform as smoothly as the list box that you saw earlier. We're at 53 frames per second interacting with the UI input. Very smooth, very simple. This is why you should leverage the GPU. OK, so turn on Enable Redraw Regions. Turn on Enable Redraw Regions. Watch your frame rate counter. Make sure that you're getting the performance that you need. Another example is from desktop. So I forgot to warm up this application. Oh, there we go. OK, so I have two list boxes, and the same goes for desktop or on Windows Phone. The one on the left is not cached. The one on the right is cached. On the desktop, this makes no difference. What we would see on the device is a very different story. The one on the left is not cached, and we're causing this redraw every single frame. And when we have the text blocks getting redrawed, we're recalculating them for the best legible experience for every single pixel. So we're recalculating the glyph and reblending them. Very expensive. If instead I have it cached, then I'm treating this entire scenario like a bitmap. Maybe it's not as legible, but it actually makes no visual difference on the white text on black. And we're basically creating it to be very smooth. We're only doing all that work on the GPU. So that's a desktop example. Same goes for mobile. And you'll notice the difference a lot more on the 1 gigahertz device than my Core 2 Duo, or I don't even know what this machine is. OK, so scrolling is done by the hardware. Text is not recalculated every frame. Faster, looks a little bit different. That's a bug for black text on white. Don't worry about that. We're going to fix that. And one can switch back to uncached text dynamically if desired. Recapturing. Less is more. Limit the activity on the threads, on the UI thread. Reserve the UI thread for input and user interactions. Leverage the render thread as much as possible. Leverage the GPU, and then debug as you go. Leveraging the GPU is very similar to leveraging a race car. Know the road. Make sure that you're watching your video memory usage, not creating and interleaving textures and creating excess. You want to basically watch your tree structure, the ordering of it, and ensure that there's a positive impact. We don't want to create textures because sometimes, extra textures, because sometimes blitting can be more expensive than a simple transform on the CPU. There are large differences from Silverlight Desktop. And I'm going to show you a diagram that you don't have to read the diagram. All you have to notice is the difference. Ooh, OK. Silverlight for the Windows Phone has this very simple story of what is getting hardware accelerated and what will successfully get cached and what will not. Silverlight 3 desktop behavior is actually very different. So when you're trying to play with a device, test it on the XDE, test it on this emulator that you have with the recent bits. Do not prototype on Silverlight Desktop. Very different story. And if these slides will be posted on my blog, so you can check out the Visio diagram yourself. Make sure you have the right tools. Like a doctor, you need to make sure that you have the right equipment to actually test your application properly. So the first thing is, can the emulator access your DevBox's GPU? On this machine, it cannot. On the CTP. On this machine, it can. And this machine's a lot lighter. Let me show you the difference. OK. So right now, we have hardware acceleration because you can see the frame rate counter up here. See that on the upper left? And as I'm just going to flick. You can see a very smooth frame rate. If, let's say, I actually turn this to balanced performance and I unplugged it, you'll see a different experience. Make sure that your dev box has the high power access to the GPU that you need. You can be debugging the wrong problems otherwise. Oh, no, wrong one. No, go back. There we go. OK. The emulator only utilizes one of the cores on the dev box. And the CPU can be more plentiful on the emulator than on the device. And sometimes the GPU will be less plentiful, depending on the battery settings of your machine. Again, less is more. Minimize the size of affected objects. If you're going to only have content on the upper portion, then minimize the size of your panels. Minimize the number of operations per frame. Minimize the number of frames and the number of activity. If your user experience is not going to be enhanced by anything, make sure it's not redrawing. So that's it. We're going to have a workshop to help shape the future. So basically, if you want to give any feedback about the Silverlight development experience, please let us know. You can either grab a card from me, post to my blog. We have actually some focus groups happening tomorrow. Susan Toe, email her, or I think you can probably contact one of us, and we'll make sure that you get on the group. It's tomorrow all day tomorrow. And so thank you very much, and please let us know what you think. We're really excited about getting this out to you guys. So let's open for Q&A. For the people that need to rush out, please take the opportunity. That's fine. And so there are 2 mics for any questions that we have, and we have the entire graphics and for a good chunk of us over here. Yes?
You said that you're about 60 frames per second right now, and when you ship, you're going to be at 30?
Yes.
Why?
Largely for battery concerns. We want to make sure that the user experience is optimized for lasting all day. Yeah.
Is the user experience going to be compromised by going down to 30 frames per second?
There's different usability studies. What I've generally seen from as standards is that the human eye can really detect something after like 30 to 32 frames per second. So we're comfortable with going down to every 33 milliseconds.
Is that something that might improve in the future, or better hardware, version 2, things like that?
So the question is, what is actually better, right? I mean, in terms of whether you want to utilize your hardware for drawing more frequently, or if you want the battery longer.
OK, well then, will that be user configurable at some point?
There are no plans for that right now. Yeah. Sorry. One thing to note is that all of the demos, did you see how nice those demos were? They were all at 30 frames per second. So we don't think that the user experience is compromised at all. Gentleman in the back.
Question on the whenever you do the display cached elements flag.
Yes.
Sometimes it draws them green, and sometimes it draws them red, and I haven't been able to find clarity what the different colors mean.
They don't mean much. Enable cache visualization will alternate between red, green, and blue, maybe. And basically, the things that are tinted are going to be software-composed textures.
OK, and when you...
Yes. No, that's redraw regions.
And
yes.
When you were talking about not interleaving cached and non-cached, do you mean as far as the visual tree is concerned, or as far as the z-index is concerned?
Good question. I said z-order. It's supposed to be the visual tree.
OK, thanks.
I will correct the slides. Thank you. Yes?
Yeah, the PDC, you showed some performance profiler for Silverlight 4. Will that work for the phone?
The Silverlight 4 profiler is enabled with the CLR for desktop, Silverlight desktop, and it is not enabled for the version of Silverlight. We know that there is no profiling tool. We know that it would greatly help everyone. We're working on the problem. Yes?
Any tools around monitoring things like network I/O and other bottlenecks that you're going to have in an application other than just graphics?
I don't think that there are any plans for this right now. I've seen a couple of people use Fiddler, just basically watching how the emulator is pinging up the network stack on the desktop. So I just lost one question. Okay, yes.
Okay, so just one question about the GPU, because such level of acceleration means that you have close interactions with silicon vendor. So I suppose Qualcomm was behind the scene also. And so one question is the specification of the driver you did in collaboration with them is open, or is it something that is simply just for you and silicon vendors?
I don't know what the rules around the hardware specs are. I'd be happy if you can get my card, and maybe we can email and I'll get you the answer.
So the question is just to know what are the primitives which are hardware accelerated from Silverlight, in fact. What are all the things accelerated?
Okay, so what's hardware accelerated right now are the JPEG decoders, the media decoders, and then the composition of the 4 properties that we've discussed: render transform, perspective transform, opacity, and rectangular clips.
Okay, thanks.
And that's the limited set. And we're looking to expand that, but not in this release.
Thanks.
Sure. Yeah. Go ahead.
You might have answered that question already. Does that include pixel shaders, or what's the story around?
Sorry about that. Yes, blur and drop shadow are also hardware accelerated.
But what if I do my own pixel shader? Will that work?
There is no API for custom pixel shaders in Silverlight for Windows Phone 7.
Oh, okay, so if I have a project that has a pixel shader on the desktop, it will not work on the Windows Phone?
No, it will not.
Okay.
The Silverlight desktop ones are actually not hardware accelerated.
Oh, bummer. Thank you.
Sure. Go ahead.
You mentioned PNG did not have hardware acceleration. Why not?
It wasn't implemented.
Okay.
Yeah.
Thanks.
Sure. Okay. Well, with that, thank you very much. Thank you for sticking around. Have a good one.